when an EIGRP router loses a successor, it checks for a feasible successor. If we don't have one, then we begin the query process. We mark our own way of getting there as active. We query our neighbor. When we query our neighbor, they freak out. They say, whoa. And in this case, R2 was probably using R1 to get there. So it says, the router that I use to get there is querying me. How bad is that? I'm going to mark that as active. And then what will happen? We will query our neighbors. They don't have an answer. They don't have a better way to go. So they will propagate this query all over the place. Now we can scope this with the stub feature of EIGRP. But the challenge is, what if I never get a reply back? What if a reply is lost? And here we're saying that a reply never comes back. Let me put in the replies. Let's say we got a lot of replies back now. R5. Nope. Actually, that's the one I don't want to have. Say R. Really? Let's try that over again. In EIGRP, if we lose a successor, we check for a feasible successor. And if there is none, then we begin the query process. That query process says, mark my own way of getting there as active, meaning actively searching for a new successor. And then we query our neighbors. That starts the active status on R2. R2 previously was steered towards R1 to get to this network that we've lost. But now R1, which was R2's successor to get to that network, R1 is querying us. We're going to freak out. We're going to say, I got to mark that as active, which we do. And then we propagate those queries further. Let's send those queries all through the autonomous system. Now, these can be scoped with the EIGRP stub feature, but we're not scoping it. Because I want you to see something. What if we don't get a response? What if our 6 replies, our 7 replies, our 8 replies? Now, what will happen is this. Let's look at our 4. Our 4 got an answer to all of its queries. And so therefore it has got enough information to reply. But R2 is waiting for R3. R2 queried R3. And R3 queried R5 and R6, but we're saying that we lost a reply from R5. That never happened. Let's just say it just went out into space. Perhaps we queried it and the CPU wasn't ready for it. And it did tail drop on the packet. Or there was corruption of the frame. We lost it somehow. It never came back. Now the problem is R3 is going to be waiting. Waiting and waiting and waiting. And R2 is going to be waiting and waiting and waiting. Why? Because it only got an answer for some of its queries. And R1 doesn't get a reply back from R2. This is a real problem. And in the olden days, I'm talking olden days, we would reset our neighborships when we didn't get a query. If we reset our neighborships when we don't get a query, we also tear down all the routes that are associated with that neighbor. All of the successors go away. We drop packets then because we can't route to the routes that we have torn down that were associated with the neighbor that might not have been involved in this particular challenge. So here's what happens. EIGRP has been fixed. If we happen to lose a reply now, and we find ourselves waiting an inordinate amount of time, we just do a stuck inactive query. We say, are you still there? Are you still working on my query to you? And if the router is still there, it will issue an SIA reply, a stuck inactive reply. We can in fact see these as message types. If I do a show IP EIGRP traffic we see these starting to creep up, we know that we need query scoping. We need query scoping because someone is dropping the ball. Some routers are getting queries and replies aren't getting back. So you start to see this creep up. Although the problem of resetting the neighborships has been solved, we still need to worry about, are we querying too far? Does it make sense to query 8 hops away to the ends of my autonomous system when I know that potentially I should constrain who is getting queried? But thankfully, the stuck inactive problem is solved.